ArcSan is now digital.ai. Join us at our booth in the virtual expo hall to learn how our app protection, white box cryptography, and threat analytics solutions can help you stay ahead of the evolving threat landscape.
Hello, everyone. My name is Brian Reed. I'm the Chief Mobility Officer here at NowSecure, and I'm here to do today's presentation at the OWASP event, Mobile DevSecOps, 5 Tips from Building Mobile Apps Used by Millions, or really Zillions. I'm excited to be leading the session today. I've been doing mobile security, mobile applications, and mobile innovations dating back more than 15 years in the days of BlackBerry. Hard to believe in that realm that we were looking at 10 to 20% of the world with mobile devices instead of 150% of the world with mobile devices today. And over that period of time, I've had a lot of experience working with different organizations, both from a mobile security deployment perspective and from a mobile application development perspective. Working with organizations like Uber and Under Armour and Vivid Seats and Sony and so on and so forth. And so today I hope to share with you the best practices we've learned over the last number of years to really help you with your mobile DevSecOps program within your organization. As we get started, let's focus for a minute on how mobile is really transforming the world. You may or may not be aware that as of last year, 70% of all digital traffic on the internet and all digital time spent is actually in mobile apps, not web. As a security professional, you may be focused on the web side of security testing, but I'm glad you're here to talk about the mobile side of security testing because that's where the traffic is and that's where the bad guys are. And so 10 years ago, the OWASP program began, and then a few years after that, the OWASP mobile program began. And that's what we're going to focus on today, really, is looking at the OWASP mobile top 10 and how to build a successful mobile DevSecOps program leveraging it. So if we think about the overall economy, it's amazing with 2.6 billion devices, 4.5 million apps in the app stores. Estimates are between 20 and 30 million mobile apps built for internal use inside of organizations. And there's millions of mobile app developers, almost as many as web developers. But we've got this giant shortage of some 3 million cybersecurity professionals. And as a panel I was on last year, I wish I could be on a live panel again, but a panel I was on last year said, the CISO of a leading institution in Chicago said, trying to find a mobile pen testing skilled person is like trying to find a unicorn on roller skates. They're very hard. So if you're looking to learn mobile as well, it's a great career advancement for you, and there's some really good opportunities in the marketplace. So when we think about innovation, before we get into seeing some cool apps and some interesting things around building a program, waves and waves of mobile innovation continue, right? Today, you can use the Mind Map AR application to actually draw mind maps over augmented reality of photos. We know about digital payments, but now we have digital car keys. I have a Tesla, I can summon my car. I have an Aura health ring, it monitors my health. If you're interested in the NBA has partnered with Aura to really work on a testing health app for use in like COVID situations for athletes. So there's all these great innovations in the market that we're all enjoying. But the reality is that some 85% of all mobile apps in the App Store have a security bug. That's pretty staggering. And some 70% of those apps leak data that would violate GDPR or CCPA. Now, we've been benchmarking public App Store data, so publicly available data as opposed to your private applications. And of course, everybody wants to build a great application, a secure application, but the benchmarks continue to show these stats year in, year out. And so what that tells us is while organizations are producing great mobile application experiences, they're missing the ball on the security side of the house. And when you dig into the benchmark, there actually are real patterns, right? So 50% of mobile apps have insecure data storage and about half have insecure communication. Almost half of them have insecure extraneous functionality. Again, these are from OWASP Top 10. The good news is most of them have secure authentication. And so what we've been trying to do is help organizations leveraging the OWASP tools, SVS, Top 10, et cetera. We're going to talk about that in a few minutes, as well as other best practices to really raise the bar on mobile security. And so today we're here to look at mobile security at the intersection of DevSecOps. And if you think about your own organization today, you may have a DevSecOps program, you may not, you may be using it for mobile or web, and you may be in one of 3 stages. There's the dark ages stage, which is the manual testing late cycle. There's the steamroller stage, which is basically development does what they want and runs over security. And then there's the automation stage, which is really what DevSecOps is all about. One of the cornerstones of it is automation and fast, friction-free pipelines. And so we'll look at some of that today through this process. So what I'd like to do is talk about 5 really interesting case studies from mega organizations doing really pretty amazing things when it comes to mobile. Some I can name, some will remain nameless as I work my way through this content. So let's talk about the first one. The first one is Uber. I'd be willing to bet everybody that's watching this has used Uber or Lyft or one of the ride-sharing apps. They're a great example of mobile first. Uber didn't even exist years ago, and it came to fruition in part because of the evolution of the mobile capabilities. They have an astronomical install base, 500 million installs on Android alone. Now imagine this scenario, right? So you're on the application security team, you're on the application development team, you've got thousands and thousands of developers all over the world. You have one single source code stack for the consumer application that actually uses feature flags and compiles, downs, and builds differently in different regions and countries. They have the ability to roll out micropayments using real cash in places like Asia or third world countries. And other places, it's a trucking application, not just, order a truck for delivery, not just order a car for a human transportation. Massive customization, yet complete centralization. And as part of all of that, they've got automated security testing at multiple layers built into their pipeline. And so while they're able to do very fast commit, test, push to prod cycles within a day, within hours, what they've got is a rigorous testing paradigm built into everything from a security, functionality, and privacy perspective, and that's driving their automation. There's a link here to an event from one of the original founding CTOs that talks about their explosion into 100,000 microservices. I'm sharing that for some background to get a sense of how complex their environment is. So let's look at another really big application you probably know, which is McDonald's, right? So McDonald's is an example of massive local customization. So from a McDonald's perspective, every McDonald's store can customize its own menu. Think about that. You've got 38,000, almost 40,000 stores around the world. That basically means 40,000 different flavors of a common mobile application to support each store, with millions of installs as well. And so again, they use a common code base. Again, they use feature flags. They use simple customization to allow it, depending on the store you pick, the menu will change, you process the order, and they have all the sophisticated ways of walk to the car, Uber Eats, deliver, what have you. So it's very excited to see what they've done. And when you look at McDonald's telling the story of mobile, they talk about a 4x growth in food delivery over the last 3 years, which is an amazing stat. We often think of pizza delivery, but they have a massive food delivery program in place. Certainly during COVID, we're all doing the food delivery thing. Now, here's a really interesting one. So this is an example of an organization that went through a strategic business digital transformation. So Allstate, you might think of as a sleepy insurance company. You've probably seen their ads on TV and so on and so forth. But Allstate is actually a massive innovation machine. And so they've delivered really amazing innovations, and they're actually driven by innovations across their technology platform. They've really become a technology company that happens to do insurance. Now, what they chose to do as part of this multi-year digital transformation is they actually build out a common infrastructure that every application team uses. They took the legacy systems and stubbed them out at the API layer. They created a common tool chain for a mobile DevOps and mobile DevSecOps, as well as a web-based infrastructure. So organizations, when they're looking to write a new application, can simply request the infrastructure that they need, the tooling, the testing, the risk, but also do they need Jenkins and Jira? Do they need Kubernetes? What cloud do they want to live in or deploy into? What infrastructure or legacy systems do they need to connect to? What database, compute power, all that kind of stuff. They request it. That's actually almost instantaneously within a few days delivered to them. And all the testing infrastructure is actually built into it. So in their world, their security testing professionals are actually spending time making sure the tooling has the right policy set up and spending time coaching and mentoring teams as opposed to manually testing everything every day. So some cool stuff on innovation at the link you see here as well. Now, I want to tell you a little bit about Vivid Seats. So you may know Vivid Seats. They're in the secondhand ticketing market. They've literally sold billions and billions of tickets. And what you may not know is that Vivid Seats not only has the commercial app you might use, but they actually run the exchange in the back end that most of the other third-party ticketing companies use as the auction house for moving those assets around. And so what they've created is small, fast-moving teams. So their mobile and web teams are very small. They're a small group of people. They're developers in QA. They don't even have security people on their teams because developers in QA are responsible for being experts in security. They have corporate security, but security is truly embedded in the skills and the knowledge set and the tooling for how their infrastructure runs. And it's really an impressive, fast-moving team to see a lot of innovations. If you want to learn more about them, the Vivid Seats engineering team actually has a blog on Medium you can have a look at, and they've got some cool stuff out there. And so finally, I can't tell you the name of this company, but they're involved in the payments world. And what's really amazing about them is that unlike the others that I've talked about that were centralized teams, this is a massively decentralized world. So they literally have hundreds of development teams scattered around the world working on different projects at any given time. And so they needed to figure out an infrastructure and a testing scheme that would enable them to deliver those mobile apps, but test locally, nationally, before and after release, and so on and so forth. So while they have some teams running in an agile world, and there may be some humans doing testing, there's other teams that are running through automation in the tool chain. Still other teams actually interface with the tooling through the public app stores. So they actually publish an application to the App Store, and then it's pulled down from the App Store, tested and verified in maybe a third world country where there isn't a local security team. That happens within a few hours, and that means that they catch anything and they fix it quickly if they have to. So there's another kind of interesting scenario we've seen here. So what I've done is I basically walked you through 5 interesting case studies, and they all have a set of common things that I want to share with you that's really the lessons learned. So the first thing is that we're all in this together, right? So security and DevOps have to be partners in this process, right? You don't want the steamroller world where development's steamrolling ahead. You don't want the legacy world where manual testing is slowing everything down, right? So working on partnership, sharing, community, enablement, finding security leaders within the development scope, all of those things are a critical thing. And everything else I'm going to talk about using techniques and processes don't matter if there isn't some level of partnership between those two teams. And we work with a lot of top tech companies and other kinds of businesses in the world. And the head of AppSec at a Silicon Valley tech company that you know well said this so well. I'd love to repeat it. And the ultimate shift left is into the mind of the developer, right? If you could take a security skilled professional and insert what they know about secure code development and put it in the brain of every developer in your organization, that would be nirvana. Right. So that means as a best practice, you need to establish a formal training and expert resources type program in your organization. So all of these organizations have a knowledge and skills-based baseline, which is you either know this or you don't. If you're a new developer coming in, you have to go through these developer security training programs. They use standards like the OWASP, MASVS, and MSTG and so forth. They have security advocates embedded in development teams. They might be security people reassigned to a development team, but where possible, they're actually trying to find developers who are willing to be a security lead on the team. They leverage courseware, they leverage training, they use outside training, they go to conferences like this. Hopefully some of you are actually from the development side participating in training like this training here at OWASP, at this OWASP global event, because it's a great way to learn and understand how to be more effective. So the second key learning is recognizing that mobile and web are fundamentally different. I bet a lot of you come from the web world. Mobile may be new to you, or you might be more advanced when it comes to mobile security testing or mobile development. But the fundamental architectures of web and mobile are different. And that means testing tools and techniques and development techniques are fundamentally different. Right? We forget about the fact that 98% of the code of a web app lives behind a firewall and has all those layers of defense behind the firewall. Right? And some code, yes, comes down to the browser, but guess what? The browser itself protects the code as well. So does the network communications, because browsers by default use SSL. You don't have to deal with certificates and all that other stuff. With mobile, it's the complete opposite, right? Almost all the mobile code lives in the wild, right? A lot of mobile apps we see are 50, 60% of the code is on the device. The rest is behind the firewall, behind some APIs. That code on that mobile device is easily reversible. You can reverse any application. The tools are there. We have open source tools, Frida and Radari, that you can use to reverse an iOS app, even if it's been DRM'd. And so as part of that, then the developer and the security professional, security testing person needs to understand those fundamental differences and adapt their testing approaches to protect against that. So if we look at the mobile attack surface, for example, understanding the mobile attack surface means recognizing that attacks come in 4 areas. So you have the code itself, making sure the code was properly written cleanly. The second is data at rest, right? So that's data storage and in memory on the device. The third is data in motion. That's the connection and the transport of data over the air. And the fourth is the API backends and what's going on with that connection to the back end. And what we find time and again, if you remember earlier, I talked about M2 and M3 as being high violation areas where 50% of the apps have issues with data in rest and 48% of the apps have issues in data in motion. That's these 2 areas. And we find that's largely because companies don't have the right testing techniques in place for mobile. And therefore, these areas are just uncovered and therefore defects escape and you have security vulns in the wild. And that's all we want to have happen. So, whether you are new to mobile or not, I'm going to walk through a quick mobile attack. So what does a bad guy do? Takes the mobile app and he downloads it and he reverses it. Lots of reversing tools out there will get me close to source code. They'll manipulate the inputs and the outputs to learn how it behaves. More often than not, you can harvest some kind of PII from an application and device as well as its communication to the back end. You might actually, during that process, discover insecure network communication and M3 violation. There's no cert validation or hosting validation. So guess what? You can inject a redirection. So now you can redirect and run a phishing attempt. Maybe that phishing attempt drives them to a place that forces them to log in again and re-give you basically all the credentials. Logging into that infrastructure, maybe you can redirect payment, as we've seen with some commercial breaches in the last year or what have you. Now you've got account takeover and you've got all this data to attack the back end. So you don't want to have this happen. You need to understand the anatomy of an attack, understand the attack surface, and then make sure you have the right testing tools in place. So number 3 here is really looking at the OWASP mobile project. They're fantastic tools. Years ago, the OWASP mobile top 10 got started because of a common recognition across many of us that web and mobile were fundamentally different. About 3 years ago, the OWASP mobile project got a boost and the MASVS and MSTG were created. Highly recommend you attend sessions about this. Take the time to download and look at the books. They're available online. There's your links here for you to go learn more information about them. The OWASP mobile project will help you truly understand what the threat models are, what the attack vectors are, where the risks are, and then the process for properly testing an application. And there's a great security checklist available at OWASP as well. Now, you're not going to learn this overnight, but what you'll want to do is think about starting where the most frequent issues are. The MSTG is like 200 and some pages, and you're not tomorrow going to suddenly have a test suite that will do all that. So if we go back to the OWASP Mobile Top 10, remember I was talking earlier about some stats. Let's look at these real quick. So M2 and M3 around insecure data storage and communication are where there's a high degree of failure. So we recommend you build out your testing suite to make sure you're covering those. What does that mean? That means DAST. The only way to test M2 and M3 is dynamic security testing. There are ways to automate it. I'm going to show you how to do that in the tool chain. M7, 1/3 of the apps have coding mistakes. Got to catch those. And then there's a lower number around reverse engineering and extraneous functionality, but they still create issues. Those can be harder to test for. They sometimes require additional human review. But a lot of this stuff can be automated. And we're going to show you how to do that in a few minutes. So when we look at the overall mission of mobile DevSecOps, it's all about automation and integration for speed. So how do I build security into my pipeline, build security into my programs, and automate as much as possible and leave the manual work behind, or make it so the manual work is only needed occasionally for high risk or complicated type scenarios that can't be automated, right? So the new world of mobile testing over the past 3 or 4 years, there's a number of vendors now that provide automated mobile AppSec testing that deliver at least SAST and DAST, and some of them deliver IAST as well. And this actually plugs into the tool chain. And what's great is because it now does binary testing. Binary testing means low false positives. SAST and IAST combined to deliver low false positives. And binary testing means you can test any language or framework. So now you don't have to worry about what language was it written in, because a lot of the SAST, traditional SAST source code tools, of course, are dependent on language. What's also cool about it is the OWASP Mobile Top 10 and MSTG can be built into this. And so you'll find tooling that will enable you to do that. And then you can tune how you want to do the testing based on the risk and the velocity of the cycle. And so when you get into automation, there's some really cool things that can happen. So when you're building your checklist for tooling for automation, make sure your checklist includes static, dynamic, and interactive testing capabilities. It is possible across multiple vendors to actually be able to do these 3 things as part of an automated testing scenario. No, it's not a mobile pen test. It takes a human expertise to do it. But imagine automating 70 or 80% of the human test in a way that allows you to plug it into an automated tool chain and run on a daily basis, right? So the capabilities are there. You can take advantage of them now and then do the manual testing when you need to. Now, as part of this, you need to run the integration cycle as well. So not only are you automating it, but you're plugging it in. So look for tooling that integrates with your CI/CD infrastructure. So Jenkins, Jira, Azure, DevOps, Bitrise, what have you, whatever tools you're using. A lot of the tools out there in the market that do automated testing will integrate. And so that basically means no human actually has to do anything. And so now you can see on the left that Jenkins build is being kicked off. When the Jenkins build completes, automatically via API and connector, the binary is passed to the automated test suite. The test suite then runs, and the test suite then generates Jira tickets. So developers and security staff don't have to log into a tool and manually run a test. The system does it for you like a smoke test or a functional test, and it automatically feeds you those tickets. Now, the ticketing you need to make sure is useful for developers to fix the issue. So make sure you get issue description, remediation, repair instructions, any context details, where did it happen, line of code, what have you, and make sure that you've got all the right information so a developer can take that ticket and fix the issue. And some organizations will choose to have a human verify the tickets on the security team before they go to dev. But all the organizations I showed you, they don't have humans in the loop anymore. After they built trust in the tools, they let it run in an automated fashion. Now, you're going to say, especially if you're a pen testing professional, what about a high-risk scenario? What about manual testing? So the reality is, for any high-risk app, absolutely, you should do an expert-driven manual full-scope pen test. Definitely do that. Leverage the MSTG to get there. But what's great about this is if you're testing 70 or 80% of the code every day in an automated fashion, that means the special stuff that the pen tester has to dig into is less of a workload. It gets rid of the grunt work, and then you can focus on the interesting stuff. Testing CAPTCHA, multi-factor authentication, IoT integration. Maybe the automated testing finds something indicative that you need to do deeper forensics on. It's really cool to watch this automation and integration occur. And those are really foundations of a mobile DevSecOps toolchain. So if we kind of bring it all together, right, it's all about integrating and automating as much as you can. And so as a security professional, you need to be an advocate and an advanced security tester yourself, but helping your organization understand how to weave and inject security into the fabric of how they operate is really a critical goal. And every organization that I talked about earlier has a multi-level, multi-element security testing capabilities. And so what you see here are the common things that we find in the most successful organization. So starting at the bottom, if we think of this as our life cycle, right? So the security training of all roles goes on consistently, and they meet that minimum security bar. Product managers are providing security requirements within applications, not just developers guessing what should to include. Threat modeling is being performed, often security and developers together. It's a great way to teach developers how to do their own threat modeling as part of the scenario. Using a variety of tools to help the developer. So these IDE plugins that are SaaS-like spell checking tools are quite popular. That's different from SaaS repo scans. That's as the developers are writing code, some of these IDE plugins are pretty good at detecting, hey, you wrote this command wrong, you chose HTTP, not HTTPS, or you're doing certificate wrong. Here's a way to properly structure a certificate setup call, and what have you. So they're really nice developer gains. SCA repo scans is critical. Mobile apps, typically 40, 50, 70% of a mobile app has open source in it. Make sure your team has a mechanism to scan those open source repos that you're bringing in. We find time and again the vulnerabilities our customers find with our tooling come from third-party open source or third-party paid libraries they embedded, not from the code they wrote themselves. I think we're all learning that open source has a big risk. It's got a big benefit too, of course, but make sure you're scanning that. Okay, so, then within all of that, as you build the app, then do your static, dynamic, interactive binary analysis as part of the cycle, feed those tickets back. Where necessary for the high-risk apps, do your pen testing. And then make sure you have a mechanism to monitor those production apps as well, right? It's entirely possible that something didn't translate right into the App Store when it goes public, or someone might be trying to resubmit your app in a rogue way. Or maybe a developer snuck past you and did a build patch and got pushed live, and you didn't catch it in the tool chain or the manual testing process, but you can catch it by monitoring the App Store or the production infrastructure. Now, all of this doesn't work if you don't have security policies and governance in place. And every organization I talked about before has strong policy and governance in place in order to make them successful. The other thing is, don't forget securing the tool chain itself. So a number of organizations have been breached through their tools. That is an emerging attack surface. So whether you are responsible for the tooling itself or others, make sure the right thing is happening, right? Make sure they're dealing with authentication, authorization, access controls. All of those things are, there's no S3 buckets left open. God, there was just another breach yesterday on that. It's crazy, right? So as a steward of security, make sure the tool chain itself and all the infrastructure of the application is secured in and of itself while you're also testing the actual application infrastructure. And so when we look at this, what's really interesting is you may be familiar with a 2020 DevOps community survey. For 5 years, a group of organizations, Now Secure, Sonatype, and others, have been publishing a DevOps community survey. And this year's survey had some really interesting data. And so organizations were filling out the survey and able to, based on their questions, determine whether they were mature, average, or immature. And so there's some striking data about the mature ones, like the 5 organizations I talked about earlier. The first one is that they use many tools. And of those tools, they use them frequently. So they're using CSA container security, they're using DAST, they're using SCA, they're using IAST, right? Best-in-class organizations choose to use multiple tools because they realize it takes a village, like the picture we just saw. The other thing that's interesting on the right, is that those who are mature are 350% more likely to use tools through the entire tool chain. So that's all of these, not just those key 5. And so as part of this, there's a link here to the DevOps survey. Good, have a look at it. Encourage you to track that in the future. There's a lot of good information in it. And when we look at governance as well, I always like to take a second on governance, because as security analysts and development teams, we still have to deal with governance and compliance typically, or we're asked by other organizations to deal with it. And those successful, mature organizations are twice as likely to include automated security and compliance testing as part of their governance program. And so some of the organizations I talked about earlier, their pipelines actually generate reporting that feeds into risk, compliance, and governance, or the GRC teams, which is pretty awesome. So a lot of information shared today. Want to summarize here. So what sets apart world-class organizations from the rest of the world is really 5 key things. They empower with AppSec training programs across dev, QA, and security. They recognize security as a skill, as a critical criteria, and they practice what they preach in terms of delivering it. The second thing is all the organizations recognize fundamentally the differences between mobile and web, and they therefore have threat models, they have processes, they have testing, they have development strategies. All of those things are run differently. The knowledge and understanding is recognized to be different. And so like the Venn diagram, some are similar, but they take care of the special things. All of them leverage OWASP, right? Industry standards matter. There's such a fantastic level of information and resources, knowledge resources available from OWASP and the community of participants around OWASP like us. And we're excited to share best practices with you like today. Practice DevOps. DevOps is all about automate and integrate everything. Let the system and the tools do the work. Enable the humans to focus on their job while the infrastructure and the tooling does the work for them. And then finally, really recognize security is not a silver bullet. Inject security throughout the tool chain and all the different places that are necessary to really bring it across. As we saw for many organizations, security is 10, 11, 12 points when you look at the overall environment that we're producing applications, and making sure that security is layered in at every different point that's reasonable within that life cycle. You can be the security champion that can bring this and really drive success into your mobile DevSecOps team. So before we wrap up, I want to share a lot of resources. You'll have all of these links. There's a great Cybrary Into class. If you haven't seen Cybrary, it's a good learning resource. If you don't know a lot about mobile AppSec, 30 minutes, you'll get a good baseline. There's resources here on how to set up the tool chain. So if you're looking at tool choices and feature capabilities and how to integrate it all together, there's some development best practices. I shared a bit around top vulnerabilities. There's a great infographic that will walk you through the top 5 most frequent vulnerabilities. That can help you and your developers figure out where to focus your work. There's a link to the DevOps survey here. We encourage you to have a look at it. And if you're big into mobile DevSecOps, there's a newsletter you can follow as well with tips and tricks you can use coming out every 2 weeks. And so with that, I'd like to thank you all for attending today. I realize we don't have live Q&A. You're welcome to hit me up at my email address or on Twitter as a follow-up. And I look forward to meeting you some point in the future. Thanks for attending our OWASP session.